In this video I am going to show you how to build a DIY command station with 5 amps or even 8 amps track current. As in the last DIY video, I built it step by step so that it is easy for you to successfully assembling your own, even if you are an electronics novice. Welcome to the IoTT channel, I am Hans Tanner. A special welcome to all new subscribers and welcome back to everyone else. I am happy you made it here. Building a modular DIY command station consists of 3 phases: buying the components, building the hardware, and loading and testing the software. Here are the components you need to buy for this build. An Arduino board, either Arduino Uno or Arduino Mega. A DCC AUX Shield to simplify the wiring. A PowerShield for the 5 or 8 amp track connection. A Motorshield or a second PowerShield depending on whether you want 1 or 2 high power tracks. An IoTT stick for locomotive and WiThrottle connections. A DC power supply with the track voltage needed for your modeling scale. Good choices are 12 volts for N scale, 16 volts for HO scale and 18 volts for G scale. As an option, you can also make 3D printed enclosure modules if you want to make it look nice, but that's up to you. I put some links for all the hardware components in the description below. With these components you can build a simple command station with 1 or 2 main track outputs of either 5 or 8 amps track current, one of them configurable as programming track. On top of that, the IoTT stick connects the command station to Wi-Fi, so you can access it using a smartphone or a computer running model railroad control software. Assembling the hardware boards really is as simple as clicking together some Lego bricks. The only thing I recommend before stacking the boards is doing a quick test to make sure the boards are working. Start with the Arduino itself. The simple test you can do is connecting it via USB port to your computer. If successful, there are 2 things that should happen. First, you should hear the Windows notification for a new USB connection. This tells you that your computer has recognized the board and that the communication link has been established. If you do not hear the notification, you may need to update the driver or possibly the hardware is not working. I recently had this problem with a Sunfounder Arduino Mega I bought from Amazon, which apparently had a dead USB port. I simply returned it and got a properly working replacement within a few days. The second thing to observe is the onboard LEDs on the Arduino. If everything is okay, the power LED will be on permanently and the second LED will be blinking with a clock rate of about 500 milliseconds. This indicates that the Arduino gets the power and that it runs the blink sketch, which is preloaded on most commercial boards. If you choose to build the command station with the enclosures, you place the Arduino board in the base and place the base frame on top of it. Next is the Motorshield. There is nothing that can easily be tested up front, so we just install it. First, we orient the shield so that the pinout matches the pins of the Arduino. On the Arduino Uno, this is a no-brainer as there is only one way to do it. On the Mega, that is the case as well, but it is slightly more complicated as the Mega has more pins than needed. To line it up, make sure that the power connectors of both boards are oriented to the left. Then place the Motorshield in the most left position possible. Sometimes it is a little tricky to insert all the pins into the holes at the same time. So here is a little trick to make it easy. I slightly bend the pins of the upper board towards the inside by pressing the board against the table. just slightly, so that the distance between the rows is maybe 1/10 of a millimeter less than the distance between the openings of the lower board sockets. This has two effects. First, it aligns all pins to form a straight row. And second, when installed, the pins will apply a small force against the contacts of the lower board, which will help to maintain secure electrical contact. Now you can insert the pins on the remote side first, then pull the top board slightly towards you and insert the pins on the other side. Then press the board down until it sits firmly on the lower board. Do a visual inspection of all pins to make sure they are all inserted in the correct hole and no pin is bent out. As it turns out, using the enclosures is beneficial for the assembly process as well, as they sort of guide the boards into the right position. Furthermore, the frames ensure a proper spacing between the boards so that no unwanted contact between two neighboring boards can happen. You may also want to connect the track wires to output ports A or B of the Motorshield, depending on what port you would like to use as programming track. When using the standard configuration, port A is for the main track and port B is for the decoder programming track. But you can connect either port and adjust it in the software configuration. The second port remains unconnected in this build, as we are using the PowerShield for the main track. And that is the board we install next. Like with the Motorshield, there is nothing that can be tested up front, but there are a few configuration options we need to take care of. The PowerShield is designed so it can work with any Arduino pin as signal source and current sensor, so we need to select the pins we want to use. The Motorshield board is using pins 3 and 12 for power and PWM on channel A, and pins 11 and 13 for channel B. Since we only used one channel of the Motorshield, we can configure the PowerShield for the pins of the unused channel. I plan on using Motorshield port B as programming track, so I configure the PowerShield to pins 3 and 12 by soldering the bridges from the pins to the power and PWM1 white bars. The PWM selector jumper needs to be in the position for onboard generation of DCC B, and finally we configure the current sensor feedback to analog pin 2, avoiding any conflict with the Motorshield, which is using pins 0 and 1. The PowerShield comes with a set of pin headers and jumpers, so it is very easy to solder in the pins and use the jumpers to make contact, and if you want to change the configuration later, you can add additional pin headers to do so. Really easy. The last configuration option to be considered is using the DC power supply of the PowerShield to supply the entire Arduino stack. This is possible if the supply voltage is not more than 18 volts. To use it, all we need to do is adding a jumper to the V-in pin header, and the entire Arduino stack is powered from the PowerShield DC supply. When done with the configuration, I install the PowerShield on top of the Motorshield and put on the PowerShield enclosure frame. Finally, we install the DCC AUX Shield. This board can be tested prior to installation by powering it with a DC supply of 10 volts or higher. Simply connect it using the barrel connector, and as a result, both LEDs on the board should come on immediately. As an additional test, you can measure the voltage between the two outmost pins of the IoTT Stick connector, which should be between 5.15 and 5.25 volts. Now you can place the DCC AUX Shield on top of the PowerShield and connect the Arduino USB port to the PC. The Arduino should start up as before, and the LEDs on the DCC AUX Shield should be on, indicating that the V-in connection between the shield and the Arduino board is working properly. As an additional test, you can again measure the voltage between the outmost pins of the IoTT Stick connector and this time you should get a voltage between 4.8 and 5 volts. If it is lower than that, this indicates that the 5 volt pin is not making contact as it should. If all this is successful, your hardware is complete and working. So, as last step, we install the Red Hat enclosure frame on top of it, and the stack starts to look like a command station. In video 116, I showed how to use the DCCX installer to load the Arduino software. Since we are using some setup options that are not included in the installer, we need to do a manual install for this build. No worries, the process is simple and well described on the DCCX webpage. It consists of two steps. First, we install the Arduino IDE, which is the tool that is used to program Arduino microcontrollers. Check your computer, you may already have it installed from other projects. If not, follow the installation steps on the DCCX and Arduino web pages and install the IDE for your operating system. If you are running a newer Windows version, you can conveniently install the Arduino IDE from the Microsoft Store. The second step is to download the command station software from the DCCX page and unzip it into the Arduino sketchbook directory. Also here, just follow the instructions on the DCCX webpage step by step. If this is your first DCCX installation, I would recommend using the latest production version, which currently is 1.4.6. If you have some experience, you may want to install the developer version and try out some of the features that might become available in future versions. Be aware though that using the developer version may require some additional effort for setup and configuration, and some features may lack documentation at this time. Before compiling and downloading DCCX to the Arduino board, we need to make some changes to configure the Motorshield and PowerShield. To do so, open the motordrivers.h file and scroll down to line 49. On this line we find the configuration of the track driver. By default it is set to using the two outputs of the Motorshield. The first line is for the main track, the second for the programming track. By default it is set for using channel A with pins 3 and 12 as main track and channel B with pins 11 and 12 as programming track. Since we want to use the PowerShield for the main track, we enter the PowerShield settings in the first line. I have configured the PowerShield to use pins 3 and 12, so there is no change there. What I need to change though is the analog input, which is A2, the current sensor multiplication factor, which for the PowerShield is 8.13, and the trip current for this channel. To make it a 5 amp output, we set the value to 5000 milliamps or slightly higher, maybe 5500. If you want to make it an 8 amp output, I recommend setting the trip current to about 8500 milliamps. Of course, such high current settings only make sense if your power supply actually can deliver that much current. If this is not the case, you should set the trip current to the maximum current output the power supply can deliver, or even slightly lower to protect the power supply. For more information and details on the configuration, you may also want to have a look at the IoTT PowerShield webpage listed in the description of this video. You now can compile and download the DCCX sketch into your Arduino and you are ready to run. After installation of the software, you can verify that it works. The simplest way to do that is using the DCCX WiThrottle software. Go to the DCCX WiThrottle page and click the Run it from the cloud option. Make sure the command station is connected via USB and then click the Connect DCCX button. You get a list of available USB ports from which you can select the one for the command station. If the connection is successful, you will see a series of commands going through the log window at the bottom of the WiThrottle page. This shows you that the command station software is working and communicating. You now can click on the power button and you will see the 4 LEDs on the Motorshield come on. The track output LED of the PowerShield remains dark as the PowerShield is not yet connected to the power supply. Click the button again and the LEDs go off. So it looks like everything works and we can go for the real thing. Connect the track output of the PowerShield to the track and place a locomotive on the rails. Keep the Arduino connected to the USB port, but also connect the DC power supply to the power connector of the PowerShield. If you did not set the V-in connection, you would also have to power the AUX Shield, otherwise it gets the power from the PowerShield. Click the power button on the WiThrottle and the LEDs on the Motorshield will come on again, but brighter this time as the voltage is higher. And this time also the LED of the PowerShield will come on. Now enter the address of the locomotive decoder and use the slider to make it move. That's it. Your command station is working. If you want to use your smartphone to run your trains, remove the power and USB connections so that the stack is unpowered. Then add an IoTT stick to the DCC AUX board and connect power again. The stick will start up automatically and try to connect to your Wi-Fi network. If it is the first time, you can use the smartphone to set the access credentials of your network. Watch video number 42 for help with this process. When connected, you can open the stick configuration page in the browser and select Loconet Loopback as command source and Red Hat Shield as head device. Then activate the WiThrottle server, and in case you want to use JMRI or other software, the Loconet over TCP server as well. The WiThrottle unfortunately does not work with Wi-Fi at this time. Also note, when using the IoTT stick, the USB port is not available as it is used for the communication between the IoTT stick and the Arduino board. You can now open the Engine Driver app on your Android phone or WiThrottle on your iPhone, and you can connect to the IoTT stick, which should be listed in the available connection section of the app. You then can assign a locomotive and use the slider and buttons on the app to control speed, direction and functions. If you want to use the Engine Driver version that has support for DCC commands, that is possible too. Start Engine Driver and set the Use Native DCC commands option to Yes before you connect to the IoTT stick. When connected, you will see the DCC icon on the Engine Driver screen. Click on it to access the additional DCC functions, namely the CV programmer. You now can place the locomotive on the programming track and click on the Read button next to the DCC address. It will just take a few seconds and the address of the locomotive on the programming track will be displayed. And by the way, there is no need to reconfigure the IoTT stick for the DCC protocol. It automatically adjusts to the command type received from the throttle. It is even possible to connect to the stick with more than one smartphone and both protocols at the same time. There is much more you can do when adding the IoTT stick, as it basically makes DCC a fully functional Loconet command station. I will do more DIY videos covering that functionality in the future, so stay tuned. For today, that's it. I hope this information was useful or at least interesting for you, and you are now eager to build your own 5 or even 8 amps DIY command station. It's really not that hard and absolutely worth trying, even if you do not have a lot of experience with electronics. Please send me pictures of your successful build or bring up your questions in the comment section of this video if you run into problems. In the meantime, please click the like button below. Every click helps to promote this video and the IoTT channel in general, because YouTube likes the likes. Thanks for watching and see you in the next video.